Good day, students! For today's video, we are going to tackle the limit laws. But before we head into our formal discussion, let us first have our learning objectives. At the end of the lesson, the students will be able to define the limit of a function, illustrate the limit laws, apply the limit laws in evaluating the limit of algebraic functions, and solve problems involving the limit laws.
So, to start the discussion, first let us define the limit of a function. By definition, a limit is the intended height of a function. As you can see from the animation on the left, the limit enables us to examine what occurs in a very tiny region around a point. We can define the limit of a function if we let f be a function and let c and l be real numbers. L is the limit of fx as x approaches to c. With that, it can be written this way. Now, let us look at this example. We can read it as the limit of fx as x approaches to 2 is 4, or the limit as x approaches to 2 of fx is 4.
Now that we have already known the limit of a function, let us move on to the limit laws, starting with the constant rule. In this rule, the limit of k as x approaches to c is equals to k. To understand more about its concept, here are some examples. Example number 1. Evaluate the limit of 19 as x approaches to c. The answer is 19. Example number 2. Determine the limit of negative 4.086 as x approaches to c. The answer is negative 4.086. Example number 3. Find the limit of 14 over 17 as x approaches to c. The answer is 14 over 17. Example number 4. Solve the limit of square root of 13 as x approaches to 1/2. The answer is square root of 13. Example number 5. Calculate the limit of negative 7 as x approaches to negative 5. The answer is negative 7. Example number 6. Obtain the limit of 2005 as x approaches to 0. The answer is 2005. That would be all for the first limit law. Always remember that if a function is a real number, then that is the limit of the function.
The second limit law is the identity rule. In this rule, the limit of x as x approaches to c is equal to c. To understand more about its concept, here are some examples. Example number 1. Evaluate the limit of x as x approaches to 6. The answer is 6. Example number 2. Determine the limit of x as x approaches to negative 2.001. The answer is negative 2.001. Example number 3. Find the limit of x as x approaches to 3.99. The answer is 3.99. Example number 4. Solve the limit of x as x approaches to square root of 29. The answer is square root of 29. Example number 5. Calculate the limit of x as x approaches to negative 5 over 4. The answer is negative 5 over 4. And lastly, example number 6. Obtain the limit of x as x approaches to 717. The answer is 717. That would be all for the second limit law, and always remember that the limit of a function is whatever value that x is approaching.
The third limit law is the constant multiple rule. In this rule, the limit of k times f of x as x approaches to c is equal to k times limit of f of x. This rule is the combination of the two rules discussed earlier. So, to understand more about its concept, here are some examples. Example number 1. Evaluate the limit of 11x as x approaches to 3. First, apply the concept, so it's going to be 11 times the limit of x. The limit of x as x approaches to 3 is 3. Therefore, 11 times 3 is equal to 33. Example number 2. Determine the limit of negative 23x as x approaches to negative 7. Again, apply the concept, so it's going to be negative 23 times the limit of x. The limit of x as x approaches to negative 7 is negative 7. Thus, negative 23 times negative 7 is equal to 161. Example number 3. Find the limit of 14x as x approaches to negative 3 over 7. Again, apply the concept, so it's going to be 14 times the limit of x. The limit of x as x approaches to negative 3 over 7 is negative 3 over 7. So, 14 times negative 3 over 7 is negative 42 over 7. Then, negative 42 divided by 7 is equal to negative 6. Example number 4. Solve the limit of 4 over 5x as x approaches to negative 3 over 2. Again, apply the concept, so it's going to be 4 over 5 times the limit of x. The limit of x as x approaches to negative 3 over 2 is negative 3 over 2. Hence, 4 over 5 times negative 3 over 2 is negative 12 over 10. 12 and 10 have the common factor of 2, so the final answer is negative 6 over 5. That would be all for the third limit law.
So the fourth limit law is the sum rule and difference rule. In this rule, the limit of fx plus or minus gx as x approaches to c is equal to the limit of fx plus or minus the limit of gx. To understand more about its concept, here are some examples. Example number 1. Evaluate the limit of 3x plus 10 as x approaches to 8. First, apply the concept, so it's going to be 3 times the limit of x plus 10. The limit of x as x approaches to 8 is 8. Therefore, 3 times 8 is 24 plus 10 is equal to 34. Example number 2. Determine the limit of 5 plus 1 over 2 x as x approaches to negative 9. Again, apply the concept, so it's going to be 5 plus 1 over 2 times the limit of x. The limit of x as x approaches to negative 9 is negative 9. So thus, 1 over 2 times negative 9 is negative 9 over 2 plus 5 is equals to 1 over 2. So for example number 3, find the limit of 4x minus 5 as x approaches to 7 over 2. Again, apply the concept. So it's going to be 4 times the limit of x minus 5. The limit of x as x approaches to 7 over 2 is 7 over 2. So 4 times 7 over 2 is 28 over 2. Then 28 divided by 2 is 14 minus 5 is equal to 9. And as for the last example, example number 4, solve the limit of negative 3/4 x minus 9 over 8 as x approaches to negative 1/2. Again, apply the concept, so it's going to be negative 3/4 times the limit of x minus 9 over 8. The limit of x as x approaches to negative 1/2 is negative 1/2. Hence, negative 3/4 times negative 1/2 is 3 over 8 minus 9 over 8 is negative 6 over 8. 6 and 8 have a common factor 2, so the final answer is negative 3 over 4, and that would be all for the fourth limit law.
The last limit law is the power rule. In this rule, it states that if n is a positive integer, then the limit of f of x to the power of n as x approaches to c is equal to the limit of f of x to the power of n. To understand more about this concept, here are some examples. Example number 1. Evaluate the limit of x squared minus 19x as x approaches to 10. First, apply the concept, so it's going to be the limit of x squared minus 19 times the limit of x. The limit of x as x approaches to 10 is 10. Therefore, 10 squared is 100. 19 times 10 is 190. Then, 100 minus 190 is equal to negative 90. Example number 2. Determine the limit of x squared plus 4x as x approaches to 2. Again, apply the concept, so it's going to be the limit of x squared plus 4 times the limit of x. The limit of x as x approaches to 2 is 2. Thus, 2 squared is 4, and 4 times 2 is 8. Then, 4 plus 8 is equal to 12. Example number 3. Find the limit of 4x cubed minus x as x approaches to 3. Again, apply the concept, so it's going to be 4 times the limit of x cubed minus the limit of x. The limit of x as x approaches to 3 is 3. So, 3 cubed is 27, times 4 is 108, minus 3 is equals to 105. Example number 4. Solve the limit of negative 2x to the power of 4 plus x cubed as x approaches to 2. Again, apply the concept, so it's going to be negative 2 times the limit of x to the power of 4 plus the limit of x cubed. The limit of x as x approaches to 2 is 2. Hence, 2 to the 4th is 16, and 2 cubed is 8. Negative 2 times 16 is negative 32, plus 8 is equals to negative 24. That would be all for the last limit law.
Now that you have already known how to apply the limit laws in evaluating functions, let us try to solve problems involving them. Problem number 1. The changes in the inflation rate of the Philippines have been monitored to follow the function f of x is equal to 3x squared minus 4x plus 5. With this trend, at what percent will the inflation be after 2 years? Based on the problem, the function is already given, as well as where x will approach. Hence, we need to evaluate the limit of 3x squared minus 4x plus 5 as x approaches to 2. Next, apply the concepts of the limit laws, so it's going to be 3 times the limit of x squared minus 4 times the limit of x plus 5. The limit of x as x approaches to 2 is 2. Thus, 2 squared is 4, 3 times 4 is 12, and 4 times 2 is 8. 12 minus 8 is 4, plus 5 is equal to 9. Therefore, the changes in the inflation rate of the Philippines after 2 years will be 9%. So, that brings us to the end of this video. We hope that you learned something about the limit laws. That would be all. Thank you for listening.